Hi everybody, welcome to quiz 6 for the scientific method. In this video we'll go through the 10 questions which are uploaded on Moodle. Hopefully you've finished those questions now. If you've not finished them, please do pause the recording and do the questions first. But all these questions are based on the scientific method, looking at variables, independent, dependent variables, and thinking about how to draw conclusions from the data that we get. So let's get started. Well, the first 5 questions are based on this passage. We can look at the first question and then we'll try and read the passage together. What hypothesis could be tested by the experiment outlined above? When potato chips are placed in solutions with high concentrations of sugar, they will lose mass as the chip will lose water because of osmosis. So they will lose mass and they will lose water when they are in high concentration of sugar. When potato chips are placed in solutions with low concentrations of sugar, they will lose mass and they will lose water. So the only thing that's different between answer A and answer B is here, a high or a low concentration of sugar. C, when potato chips are placed in solutions with high concentrations of salt. Okay, so this time it says a high concentration of salt, not sugar. They will lose mass because they will lose water through osmosis. And then the last one, when potato chips are placed in solutions with high concentrations of sugar, so we're back to sugar again, they will gain mass because they lose water. Okay, so let's look at the passage. Diffusion is the movement of particles from a high to a low concentration. So particles go from a high concentration to a low concentration. Osmosis is the diffusion of water across a membrane. Active transport moves particles from low to high concentration. So scientists investigate the effects of osmosis on living cells. They observe with a microscope the cells or tissues placed in different solutions of different concentration. They can also measure changes in cylinders or discs of fresh potato. Cylinders have a larger mass than discs, so scientists will have larger measurements to work with. And they do this experiment in different concentrations of sucrose. Now, sucrose is a sugar, not a salt. So because we're looking at sucrose, we can take away answer C. So, prepare a range of sucrose solutions. Set up a series of boiling tubes with each of the solutions. The 0% sucrose solution will act as the control. Make sure that each tube is labeled. Prepare the blank results table. Make sure that when you weigh the potato cylinders, their masses are not mixed up when you record them. Each cylinder will have a different mass before and after the investigation. Dry the potato using a paper towel. Measure the mass of the potato cylinder. Place the potato strip into the solution for 20 minutes. Remove the potato strip and dry it carefully using the towel. Measure and record the mass, and then repeat for each of those sucrose concentrations. Now, what hypothesis are we testing? Well, we're testing about osmosis. We can see osmosis is in each of these answers. What happens in osmosis? Particles move from low to high concentration. So where will the low concentration be? Where will the high concentration be? So don't get confused. Diffusion and osmosis are different. The diffusion goes from the high to the low concentration. Osmosis goes from the low to the high concentration. So the water is going to the high concentration area. So answer A, in a high concentration, and then answer D, also in a high concentration. At this point, we can take away answer B. So if the potatoes go in a high concentration, will they lose mass because they lose water, or will they gain mass and lose water? Well, mass is the sum of all the particles inside an object. If it loses something, then the mass will go down. If it gains something, then the mass will increase. So the correct answer must be A. If it loses water, it must lose mass. So what will be the dependent and the independent variables? Well, there is a range. A range means a variety of sucrose solutions. So the strength of the sucrose solution, 0, 20, 40, or 100%, this is what is being chosen. So this must be the independent variable. What will be measured? Well, talk about larger measurements here. And what are we looking at? What are we weighing? Well, they're looking at the mass of the potato cylinder. And then they measure and record the mass of the potato strip. So that word measure and the action of recording show that we're looking at the dependent variable, and then looking at the mass. So we're looking at the change in mass because the mass is weighed at the beginning and then the mass is weighed at the end. So what is going to be looked at is the change in mass over those 20 minutes. So the dependent variable is the change in mass. Which of the following could cause an error in the investigation? Now, an error could be a human error, a mistake that a human makes. An error could be a mistake in the design of the experiment. Maybe there's more than one thing that is changing each time. Maybe the equipment is not accurate. All of these things can create errors, and when people want to do these experiments, they need a control to compare things to. They need accurate equipment for measuring the changes. They need to control all of the variables apart from the designated independent variable. Well, A, having different sized potato cylinders at the beginning, would that be an error? Well, no, because at the beginning, the mass is measured. So because the mass is measured at the beginning, there's no problem. The mass is measured at the beginning and at the end, and so the person doing the experiment can calculate the difference. It would be almost impossible to get absolutely identical pieces of potato at the beginning of the experiment. So this is not a source of error. B, not drying the potatoes with paper towels. And then D, drying the potatoes with paper towels. Now, if you look, both times when potatoes are going to be measured, they are dried with a paper towel. Why are they dried with a paper towel? Well, this is to avoid having an error. If the potatoes were not dried, then the person doing the measurement would be weighing the potato as well as the water on the outside of the potato. The experimenter only wants to measure the mass of the potato, nothing on the outside of the potato. So by drying the potato first, any extra water that's on the outside surface will be removed and the mass will be calculated for the potato only. So drying it is actually a good thing. Drying is good. This is not an error. Not drying the potato would be a problem. If it was not dried, then when they measure it on the weighing scales, they will be measuring the potato as well as the extra water. See, repeating the experiment, well, repeating something is never going to be an error. Repeating the experiment is a way to remove potential errors. So, Because this question is asking for causing an error, we're looking for something that is bad. B would be a bad thing. B could cause the experimenter to get inaccurate results. And then look at the results table above. What is the average percentage change for potato cylinders at 0.6 mol to minus the power 1? So we can highlight this part here, and we can highlight this part here. At each of the concentrations, it was measured 3 times. So at 0.6, it was measured 3 times. And the person doing the experiment has calculated the average percentage change each time. But what we need to do is calculate the average for these 3. So if you take your calculator, you need to put in minus 26.72, minus 23.89, and minus 22.43, and divide by 3. And you get 24.3466666666. So if we go to 2 decimal places, we would put 24.35. But remember, this is minus 24.35. Why is there a minus? Well, there's a minus because it's getting smaller. If you look here, when it was pure water, the potato actually increased in size. When there was a weak sugar solution, the potato increased in size a little bit. When the solution started to become more stronger, it started to decrease in size. And when there was a very strong sugar solution, the change in size was very dramatic, reducing by around 1/3. Finally, based on the results, so looking at that table, what conclusion can be drawn? The chips gained mass in high concentrations of sugar, but lost mass in pure water. Well, that's the wrong way around. For the high concentrations of sugar, the 0.8 and the 0.6, we get a negative change in mass. A negative change in mass means they are losing mass. For the pure water, there was a positive change in mass, so they were gaining mass. So A is the wrong way around. B, the chips gain mass in all the experimental conditions? Well, no. If you look at the change in mass, the percentages, there are some positive and there are some negative. So some of them were gaining and some of them were losing. They did not all gain. And likewise, in D, they did not all lose. So it looks like the correct answer might be C. The chips gained mass in pure water. That's true because there was a positive percentage change. But they lost mass in the high concentrations of sugar, which is also true because there was a negative percentage change. Which procedure would increase the validity of the conclusions from this experiment? Increasing the number of times the activity is repeated, decreasing the number of students participating in the activity, eliminating the data where resting pulse rate is taken, or changing the temperature in the room before and after the exercise. We've looked at a similar activity to this before. Students in a class recorded their resting pulse rates and their pulse rates immediately after exercise, and the data is shown below. We have 5 different students with their resting pulse and their pulse after exercise, and every one of them increased. So according to the data, the average pulse rate immediately after the exercise was higher than the average resting pulse. So the exercise caused the heart to beat more quickly to push blood around the body. How could we increase the validity of the conclusions? Well, if we eliminate the resting data, if we took away the resting data, we wouldn't know if the heart rate had increased or decreased. So this cannot be the correct answer. Decreasing the number of students. Well, experiments are always more accurate the more times they are done. The more times you can repeat it, the more times that you can show that this is true, the more accurate and the more reliable your experimental data. So decreasing the number of students is not good. Actually, we want to increase the number of students. D is not good because changing the temperature means there would be two variables. There would be the variable of exercise and also the variable of temperature. And then the change in heart rate could be because of the exercise or it could be because of the temperature. When we're doing the investigation, we try to have one independent variable and then we can attribute the change in the dependent variable to the change that we made in the independent variable. What are the independent variables and the dependent variables in Alicia's experiment? Alicia wants to test the effect of different materials on the melting rate of ice. So the effect of on. So this is the cause and this is the effect. Any more words that will help us? Well, she covers 3 pieces with different materials. She chooses 3 different materials. So the type of material would be the independent variable. So we have independent variable as a type of material there, and we have type of material there. So we can take away C and we can take away A. Let's continue. The melting rate of ice. So she's going to be measuring how quickly the ice melts. So the dependent variable is the speed at which the ice melts. So the time the ice takes to melt, the speed at which the ice melts, D is the correct answer. If you look at B, the mass of the ice, well, she is probably going to be using the same mass of ice each time. That would be something that she wants to control. Her hypothesis is that some materials will slow down the speed of melting. Which of the following is a strength of Alicia's experiment? She covers a total of 3 pieces in 3 different materials. Now, this is not really a strength. If she had 9 pieces and 3 pieces were covered in tin foil, 3 pieces were covered in plastic, and 3 pieces were covered in paper, that would be a strength because she would be repeating it. But only doing 1 piece of ice in tin foil and 1 in plastic and 1 in paper, this is a weakness, not a strength. So we can remove answer A. She leaves 1 piece of ice uncovered so that she can compare the rate of melting to the covered pieces. Yeah, this is actually a very important part. This would be the control. If no material is added to the ice, how long does it normally take to melt? The control, the normal. So if it takes longer when it is covered in tin foil, plastic, or paper, then those materials slow down the rate of melting. If it takes less time, then those materials will be speeding up the rate of melting. But we don't know if they are speeding up or slowing down unless we know what normally happens, unless we have a control. So B is a strength. C, she places the ice in different containers of water, in different containers. This is again a weakness. Different containers of water may have different properties. They might be slightly different temperatures. There might be bigger or smaller. They might be in the sunshine or not in the sunshine. There might be different things in these containers that could increase or decrease the rate of melting. So that is also a weakness. And she chooses both metallic and non-metallic materials. This is true. She has tin foil, metallic, plastic, non-metallic, but this is not a strength and it's not a weakness. This is just a description. She does do this. This describes what she does, but this is not a positive or a negative. so we take that away as well. A and C are both weaknesses of the experimental design. D is not a strength or a weakness. B is the answer we're looking for. Question 9. Based on the data and the test conditions, which is the best explanation for why the boiling point of water is 2 degrees below the accepted boiling point? A. All the temperatures were carelessly recorded. B. The beaker was uncovered so heat escaped. C. The thermometer was slightly inaccurate. Or D. The accepted boiling point of water is wrong. The boiling point of pure water at sea level is tested. The water is placed in a beaker over a Bunsen burner and heated. The same thermometer, so that's controlled, is used to measure the temperature in 3 trials. When the water boils, the temperature is recorded. Here are the results. In trial 1, the water boils at 97.6 degrees. In number 2, it's 97.8 degrees, and in number 3, it's 97.6 degrees. Since the 3 measurements are nearly the same, well, 0.6 and 0.6 is the same, this one is only slightly higher, the temperature readings can be considered to be accurate. However, they are more than 2 degrees lower than the accepted boiling point at sea level, which is 100 degrees. You should know that water boils at 100 degrees Celsius. So why? Why, when this person did the experiment, did they find that water was boiling at 97.6 or 97.8 degrees? Well, if you chose answer A, all the temperatures were carelessly recorded, I don't think you can say that. 97.6, 97.8, 97.6, these are all very close to each other. It looks like the person doing the experiment looked very carefully, not carelessly. So they were carefully recorded. Answer A is not true. The accepted boiling point is wrong. Well, you would have to be very proud of yourself to say, I have boiled water 3 times, and now I can tell the whole world that they are wrong. Water boils at 97.6 degrees. You would also be very foolish. Just because you've done something 3 times does not mean that you have found a universal truth. People have been boiling water for thousands of years. Scientists have looked at the temperature that water boils for hundreds of years. It's been done millions of times around the world, and scientists agree that 100 degrees Celsius is the boiling point. So if you do it 3 times and get a different temperature, then you are probably wrong. So we do not change what everybody in the world believes just because we do something 3 times and get a different answer. So take away answer D. So we're left with B or C. The beaker was uncovered so the heat escaped, or the thermometer was slightly inaccurate. Well, if you think about it, any container or any pan that's got a fire under it will be losing heat. It will be losing heat through radiation. If something touches it, like a hand, ow, you will lose heat through conduction. If there's no cover, then you'll lose heat through convection. But just because you're losing heat does not mean that the water has to boil at a lower temperature. If the water does not get to the boiling temperature, it would just stay as water. So why did the water boil at 97.6, 97.8 degrees? It's not because heat was escaping. It's true that heat was escaping, but that's not a good reason why water was boiling at a lower temperature. The best answer, the thermometer, is a little bit inaccurate. Answer C. We can see that all 3 recordings are very, very similar, which suggests that the thermometer is being used accurately. But if the thermometer is set to the wrong temperature, then the reason why all three answers are so similar is because they are all coming to 100 degrees, but the thermometer is broken. The thermometer thinks 100 degrees is 97.6 degrees. The amount of mercury, the liquid in the middle of the thermometer, might be slightly inaccurate. So C is the best answer. And then last question. Does the data support or dispute the MFRTA theory? Answer A and B. The data does not support the theory. Answer C and D. The data supports the theory. So it does support or it does not support. First question, what is the MFRTA theory? Mitochondria make 90% of the energy needed by the body to sustain life. The mitochondrial free radical theory of aging, MFRTA. Okay, so we see that in the question and we see that here. So now we can find out what the MFRTA is. Theorizes that individuals who live the longest produce fewer mitochondrial oxygen reactive species. So those individuals who live longer have less mitochondrial oxygen reactive species. Therefore, lifespan will increase. Lifespan is longer if there are fewer MTROS. And lifespan will be decreased, will be shorter if there are more. So more MTROS, less life. Less MTROS, longer life. And an experiment was done to test the theory, and the results are shown below. The 4 test groups of flies were involved. There were 2 groups of females and 2 groups of males. That is strong. If there was only females, then the results could be biased, and the same if there were only males. So 4 groups, equal male, equal female, this would be a strength of the study. Now, they only live a few months. Which is the longest? 120 is the longest, and then 110. But how about the number of MTROS? Well, 2.5 is the fewest. That's a good start. People that live longer, lifespan increases if there are less MTROS. So the longest lifespan has the least number of MTROS. How about the shortest? Well, the shortest is 89 days. But that's got 2.7. 2.7 is the second fewest number of MTROS. And the passage said lifespan will decrease, will be shorter if there are more MTROS. So for the fewest number of days, there should be the highest number of MTROS. The 39 should be over here. So this data does not support the theory. Why? Because there is no inverse relationship. If we have the days, the longest days is 120, and then we have 110, then we have 95, and then we have 89. The 120 days has only 2.5 MTROS. That's good. But the 110 days has 3.9, the longest. So that does not support the theory. 95 days has 3.2, which is kind of okay, but 89 days has 2.7, which is very bad. It should have quite a big number of MTROS. So because of this and this, the data is not supported. There is no inverse relationship. Remember, the inverse relationship is when one increases, the other decreases. So as this goes down, this side should be going up, but we go up and then down and then up again. So it doesn't really make sense to go up, down, and up. These numbers do not show an inverse relationship. So answer B says it does show, answer A says it does not show. So answer A is correct. I want to encourage you, if you get something like this in your exam, something that you've never seen before, you might panic. But first, look at the difference between the answers. We separated these answers into two sections. Those that said the data did support and those that said the data did not support. Secondly, find out what is being tested. Thirdly, look at the data. Data is just numbers. Even if you don't understand exactly, you can see that lifespan, so lifespan comes down here, and the MTROS, so that comes down here. You can match words from the paragraph to the table. You can match words from the answers to the paragraph. And then you use your reasoning skills. So if you get something that you've never seen before, don't panic, just take it step by step. Also put a red flag on, and if you think you will run out of time, you can always come back to these questions at the end. Osula Psycho there.